Uh, Hello, this is Naireza Alvin. I'm working on inverse reinforced deep Q knowledge distillation for credit risk prediction. I'm working with Mayanja Janet, and this is we're here to show how we built and deployed the model. So we built a model for graph neural networks to handle credit risk prediction, and we deployed it using Django. We used Django's built-in view handling to process API requests instead of Flask or any other tool. So we are using Django entirely. So first we set up a Django project. The Django project, it has the name. This is the project name here, and the project comes with its settings and URLs and other files. Inside the project, we have an app. Our app is called Predictor in this case. So right after creating this project, we go to settings, and since we have a new app now, we come to settings and add the new app. Our new app is called Predictor. We added under installed apps, as you can see here, so that it can be recognized. So now that we have added a new app, we have to update the URLs for this project so that they can be able to the URLs for the app. This is the line this is the line you add, so that the project can see the URLs for the app, which is Predictor in this case. Continuing, after modifying the URLs, so now we train the model for credit risk prediction model. We imported all the requirements we needed, and we trained it. After training it, we had to save it using Torch. This is the line that saves the training model, and after training it, now we have to use it to make the predictions. We are going to load the model in the models.py. This is the file where we are going to load the model. This is the code for loading the model. We are loading the trained model. After loading it, we created a prediction function. This is the function that is going to handle the prediction based on all these features. And then, yes, and then convert these features to tensor, and then return the prediction. So after that, after creating the prediction function, we had to create a user interface for the application, and I'll let my colleague to pick it up from here with the user interface in this form.
Hi, my name is and I'm going to take you through the remaining parts for the data that we created, like a form where users will just input their borrower data and then get a response for that it is accepted or rejected. So these are some of the features that we put, and we added the required such that you have to fill every field. If you don't, then you don't get any. When you submit, you get any results, or you can't even submit. So coming down here, then this is what helps us like to display the results. So prediction result, you come up with like the prediction, either if it's rejected or accepted. So after that, we went for the deployment part, or like handling the submission. And this is in check views. So we use the post method to handle submission, and the post method to handle submission. So when you upload all like these features to the interface, the process to the post method, and then like stored in a database, and then you have to convert this data that the model receives into a graph, since we're using graph neural networks. And then after they've been like turned into a graph, then it's going to like make the predictions. This is like the prediction function. And if you get a prediction of like a 1 that is no default, then your loan is approved. Otherwise, it's going to be rejected. So we have this render function. It's just going to help us like return the page. The same form, like the same HTML page. So after that, we went for deployment. Just created the requirements txt file, which is this one, and then you run a command pip freeze -m requirements to txt, and then it's going to upload these files in here. These requirements which you install, and they're going to help you in deployment. So when it comes to deployment, we use render, and then we use render, create it like a GitHub repo, pushed our code, and then connected it to render, and then requested for their web services. So after that, you have something like this. This is just render checking for all the requirements that you installed in the requirements.txt to see if you have them. And then if you do, your server is going to be live. They'll give you a server. So so this is like our URL. When you click it, it must take you directly to this page where you feed in borrower data, gender, like anything. We have a 1 and 0, just feed in like a couple of details for the applicants. Applicant income, co-applicant's income, the loan amounts, the long term, the credit history, like property area 0, and then submit. And then it gives you a result, either rejected, this is rejected, or accepted. So that's it for our ML operations. That's how we deployed our model.